So, you guys got my email from yesterday, right? Were you guys able to access the Google Drive folder? It should have like a Google Colab like notebook. And just to let you know, guys, that all the notes are in there. So if you missed anything, like if you couldn't follow up taking notes during the workshop, don't stress about it. And my workshop concentrates more on like, I want you to practice with me. So I'll be typing all the code on my end, and then please have your IDE open or your Python shell open and do type with me. Okay, so now we'll start with a quick review of our workshop one that we had last week. So we'll do a quick review in data types. So we had a building data types in Python, and it's a very important concept, and variables can store data of different types, and different types can do different things. And Python has the following data types built in by default. And in this categories, we call it arrays or Python collections. And there are 4 collection data types in Python programming languages, including lists, tuple, set, and dictionary. List is a collection which is ordered and it's changeable, allows duplicate members as well. Tuple is a collection which is ordered and unchangeable and allow duplicate members. Set is a collection which is unordered and unindexed, and no duplicated members allowed. While dictionary is a collection which is unordered, changeable, and indexed, and no duplicate members. So in Python, the data type is set when you assign a value to a variable. And here I'll give some examples. Let's have a variable x, and let x is 1. We assign 2.8 to y, and z, we assign 1j to z. And please keep in mind that the equal mark in Python is actually not equals we did in math. It's more like we assign certain value to a variable, and equals in Python has 2 equal mark. So this is equals. And we have, let's give another variable called w. And let's put a bunch of numbers in here. One last variable, let's do s. And now we have 5 different variables with different data types. And now we can take a look at what data types they have. Remembering our last class, we said if we're not sure about which data type of this variable, we can always use the function type parentheses. And let's do this. Let's print out all the types of all the variables we just assigned. And we run it. See, in the console, we see an output of class. The first x is integer, and the second is a float. The float is basically a number that with decimal numbers. And the third one is a complex, which means it's a combination of multiple different data types. As we can see, 1 is an integer and j is not an integer. And the fourth one, w, is a list. List is basically a bracket, and you can put in strings, numbers, aka integers or float, or all the data types in your list, or even you can put a list inside a list. And the last one, as with hello, is a string. So the way we recognize it, a string, is it always have quotation marks, and everything inside 2 quotation marks is strings. And let's do another review about data conversion. So you can convert from one type to another with functions int, float, string, etc., or even complex. So now if we want to convert from an integer to a float, so we can do a is an integer, and then we want to come x, let's do x. X is an integer, we want to convert it to a float. And let's call it a. And run it. Oh, sorry, I forgot to print. If you're using Colab, you can just run it. You don't have to do the print step. But if you're on IDE, you'll have to have the print to have it show on the console. And now x originally was 1, and now it became 1.0 as it changed from an integer to a float. And one more, let's convert from float to integer. So b, assign b to integer. Let's see what we have. Y was a float, and now it's convert y to an integer. Yes, class means a data type. And now on the float, originally it was y was 2.8, and now it would only, when we're converting the float to integer, it would only keep the integer part, which was 2. And we can convert from integer to complex. For example, and let's convert x. Oops, wrong side of print. And now we can see that originally the x is just 1, and then with the complex, it became, I added a 0j to it. And that's a quick review of data types. We can also do string and other ones as we covered in last workshop. I'm not going to go too much into it. And there's a function in library called general random numbers. And Python does not have a random function to make a random number, but Python has a built-in module called random that can be used to make random numbers. And that's like a library. I will delete this. And we import random, print random. Random range. Let's generate a random number from 1 to 100. And what's inside the random range parentheses is first index, aka where you want to start, and last index, where you want it to end, and the step number. So you'll notice every function that's related to a range, it's first, last, and steps. And now let's print this. So it randomly generated a number of 59. So every time it's run, it will randomly generate a number from 1 to 100. And you may ask, like, why we need a random number. It's sometimes when you have a function or you build a program and you want to test your program if your program is working, and then you don't want to go import a database, then you can just do a random test by importing the random libraries. I will go deep into libraries in our next workshop. Right now, we don't have to worry too much about libraries. Okay. And now let's go into today's workshop. Today, we'll first be covering conditions, loops, and functions. And later, if we have time, we'll do an introduction to pandas and do some practice. If we do not have time, then the pandas and Matplotlib will be moved to the next workshop. Okay, so let's start with Python conditions and if statement. So Python has three conditions: if, elif, and else. And Python supports the usual logical conditions from mathematics, which means if we want to do equals, as I mentioned, one equal mark does not mean equals, it means a sign. So in order to do equals, let's say 1 equals to b, then we do 2 equals mark. And not equals is a factorial mark, not equals to b. And less than is obvious, a is smaller than b, a less than b. Less than or equal to is a less than or equal to b. Greater than would be a larger than b, and those are just like basic mathematics. And greater or equal to would be a larger or equal to b. And this is very straightforward. And the if statement is written by just using the if keyword. And now let's go into a flowchart. Let's have assign 32 to A and assign 100 to B. And now we have two variables. And let's say let's set a condition. If B is larger than A, we print B is greater than A. And see, yes, we did meet a condition that B is greater than A. And in this example, we use two variables, A and B, and which are used as a part of the if statement to test whether B is greater than A, as A is 32 and B is 100. We know that 100 is greater than 32, so that we print the screen that B is greater than A. And the indentation is an important part in Python. If you had background in other programming languages, some are not so strict about indentation, but Python relies on indentation, aka a white spot at the beginning of the line to define the scope in the code. And other programming languages often use a curly basket for this purpose, but Python doesn't. And now, followed by the last example, we can do an else, right? Let's add an else. Else print B is not greater than A. And this time, let's set A to 200 and B to 100, and we run it. As obvious, A is larger than B this time. So now the program to print B is not greater than A. And what if they're equal? It will print the same thing because the system first goes through the first if statement and realize that, oh, B is not larger than A. So everything would go into else and print B is not greater than A. And now we can, as we mentioned, the both A and B are equals condition. Now we can add elif, which is the keyword that Python used. That means a way of saying if the previous conditions were not true, then try this condition. So now we can add an elif in between. Elif, we have a condition that A equals to B, and we print A and B are equal. And now let's print our statement again, and then we see that program will return A and B are equal. And the last condition is not greater than anymore. It would be B is smaller than A, right? So the only possible condition is B smaller than A. So in this example, as the past example that A is equal to B, so the first condition is not true, but if L condition is true, we print to the screen that A and B are equal, even though the third one, it will not even run through the third one. And let's give it one last example. Let's do A is 330 and B is 33. And in this example, A is greater than B, so the first condition is not true. Also, the else condition is also not true. So we go to the else condition and print to the screen that A is greater than B. And let's run it. I'm sorry, A is greater than B. And now let's do a quick exercise. I will copy paste the exercise questions to my screen and the chat, and you guys can practice it. 1 second, let me do. Here, let's question. Here is a practice question. And I'll put in the chat too. I will give you guys till 3:20. Please try to figure this question out and we'll go through the answers together. Okay, do you guys need any more time or you guys figured it out for this practice? I would take that as a yes, and let's work on it together. So we have, in this exercise statement, we have A, B, C, or X, three different variables, right? So let's do A is randomly 450, and B, we assign it 76 to B, and we have C, I use C instead of X, so it's either. And we have a condition that print out B is larger than A, B minus A equals to X, or A and B are equal, A equals to B equals to X shows the result of B minus A, or the value of A and B. I guess this exercise question was not so clear. So basically, it's the same condition as we had in our example. Either we compare A, B, and right now we don't have C. Apparently, X is just a new random variable. So if A larger than B, print, I'll copy, A is larger than B. Then A minus B is and we want to get a result of A minus B. And as we mentioned in our last workshop, that we can just do basic calculation inside the print function. So if we want a result of A minus B, instead of assign a new variable to it, we can just do A and B in the parentheses. And elif oh wow, someone already used input. Yeah, that's smart. And right now I'm not gonna cover input. I'll just use very blunt and straightforward comparison. And A minus equals to B equals to, we want it to the X would be A. Or doesn't matter, here it can be A, it can be B. And the last one is else. Print A is smaller than B. Okay. Now let's run it. Right, so we get a result that A is larger than B. Let's get a period here so it's not confusing. And A minus B, it will return the result of the difference between A and B. So now, right now our example is very easy, and it may get complicated in the future if the if statement is longer or we have multiple ifs. And right now I'll draw a quick flowchart to show you guys how this process works. Let me change a share content. Okay, so for if statement, each has a flowchart behind the statement. So sorry. For if, the first we have, let's say, a value or a variable that we go into our test expression. And it has two conditions if it's true. As we mentioned, oops, TRUE, not U. As we mentioned, their true and false are called Boolean data types. And we go through the body of if, the if condition. and then print out the result. And if the test expression is false, we will not go through the body of condition, but we will return directly, jump outside of the body condition, and then return to the result. Or sometimes if you don't set it, it would return to 0. Not 0, but like no result would show. And the next flowchart, let's do if-else flowchart. If else. And how this works is, again, we have input, and then we run through the test expression. And again, determines if it's true. I keep spelling it opposite. If it's true or false. And then if it's true, we do body of if. And then we print out the if statement inside the body of if. And then if it's false, and then we go to, now we have one more, the body of else. Right. And now it will print or return what's inside the body of else, and then jump out of the loop or the condition. And now let's do the most complicated part, the flow chart of if, else, and else. If, elif, and else. If, elif, and else. So how this works is we have input again, and then we go through test expression of if, of the if statement. And then determines if it's true or false. If it's true, and it will run to the body of if, and will just return the result. And if it's false, what we would go is we go to the test expression of elif. And if it meets the condition of elif, it will print or conduct the body of elif, the command. And then jump out from the loop. And however, inside the elif, if it still doesn't meet the elif condition, it's false, right? Got into your way, sorry. False. aka does not meet the elif statement, then now we go to the body of else. And then now we return the body of else, and then we jump out from the function. And this is a flowchart of the logic behind all those conditions. If you have time, you can take a look, or if you have any questions, let me know. And now let's go back to PyCharm. Again, don't panic about writing it down. It's all uploaded in the Colab notebook inside the Google Drive folder that I shared with you guys. Okay. Are you guys seeing PyCharm now? Okay, I'll take that as a yes. Okay, so now after if, elif, and else, we can add there is and or. So and and is the key. The and keyword is a logical operator, and it's used to combine two conditional statements. What that means is, so we use the same ABC. And we can do if A is larger than B and C is larger than A. We print both conditions are true. Both conditions and else, right now we don't have elif, and else we print conditions not meet, right? We ask this function to meet both conditions and conditions not meet. And let's run and see the result. So we see that the variables we have right now does not meet the conditions that both conditions that A is larger than B and C is larger than A. And we have a condition statement called OR, which means this key is another logic operator and is used to combine a conditional statement. What that means is that if let's say A is larger than B or C is larger than A. So that means, I'll get rid of B for now. At least one of the conditions is true. And let's run it. And on top of that, on top of if, we have a nested if. This gets a little bit complicated. Nested if. So I'll write the definition down is that you can have if statement inside if statements. So basically under a precondition if, we still have multiple options inside it. And let's start from beginning. Let's ignore the code we had before. And let's assign a variable called x, and x is 18. And if x is larger than 10, we print above 10. And if x meets the circumstance that is larger than 10, we want to double check if it's larger than 20. We print and also above 20. I'll add a period here just to make it clear when we print. And else print, but not above 20. So what we have noticed here is the indent. This both if and else indent is after inside this if condition is that x is larger than 10. So this condition needs to be made to be met in order to run through the logic inside the if. And let's run this function. Oops. So as x is 18, we got a result that input is above 10 but not above 20. And if it's 38, then we got returns that it's above 10 and also above 20. Right? That's a condition statement. And now let's do a second exercise with nested if. Again, give me 1 second. Let me copy to the exercise. And I'll oops, put it here. And here is the exercise 2. I will also post in the chat in case you guys didn't see it. Here. So I posted in the chat. Right now it's 3:36. I will wait until 3:42. 5 minutes, 6 minutes should be enough to quickly run a condition. Okay, good luck, everyone. I'll wait for 5 minutes, and please try to do more practice. Otherwise, once you go out of workshop, you'd forget everything. Yes, I saw a question asking if when they try to use an input, I have the error saying the string. So which means we need to do data converting, right? Mhm. Yes, so if you convert it to an integer, it should work, right? Okay, let's work on this together. Do you guys need more time or are you able to figure it out? All right, I'll take that as a yes. So you guys probably saw someone, Elaine. Sorry if I pronounced her name wrong. I'm so bad at names, but yeah, she brought up a very good question about input function. So let's start. And you guys can probably know the answer from her input as if we do an input function, which allows user to key in a random number on their end, it's a string. And then what we need to do is we convert it to an integer. So what we do is we do an int. Remember that's a function that we use to convert other data types to integer, and then we do input. And let's enter a number. So that allows the user to enter a number in their end, and if num larger and equals to 0, because we want to test if it's positive or negative, and if not equals to 0, we print 0. All right, now let's run this. So here we can see in the console, okay, let me comment those so we won't get distracted by our old code. And now we enter number, let's do 20. And it returns positive number. And now let's run it again. To -10. See, it's a negative number, and then run it again. We got 0 and 0. So in this program, a little function, we have two different big determination process and two small determination process under the first condition, right? So the first condition is we want to test if this number is larger or equals to 0. And then there are two conditions meet under if it's larger or equals to 0 is that it is 0 or it is positive, or the else b is negative. Again, you can, instead of using a nested if, or of course you can also use if else and else condition. But here, as the exercise asks you to do a nested if, and that's how we do it. And again, there are multiple ways of doing that. You don't have to use exact the same code as I did. As long as your program or function is running, then you're right. Okay, and now let's go to the next step is shorthand conditions. So shorthand conditions is basically just similar to what we covered. It's just a different syntax, or we call it another way of using it. I'll quickly show you how this works. Shorthand conditions. Short. So sometimes people get confused by indent and stuff, then we can do like that. If A is larger than B, print, oops, print. And see, we can put them together. Before we did like that, we do like two lines, and here we just put them together in one line. That is fine. And now we define A is 890. Okay, we don't need an indent over here. B is, let's do 330. If you can put in whatever, and then we can do this print A if A larger than B, else print B. Yeah, and let's run it. So this is a different way of writing an if-else condition, and print it just everything in one line. And that's why we call it shorthand condition. And we can also do two else and else if. For example, we do print A if A larger than B, else print equals if, else print equals if A is equals to B, else print B. So here has a three part: print A if A is larger than B, else print equals if A equals to B, and else print B, right? So now we do both, assume both are 330. And then it would print, I think there's an issue over here. Let me see. Print A if A if A larger than B, else print equals if A equals to B, else print B. And A is 0, B 0, How weird. Let me see. If print equals print else print B. Oh, right. The value didn't match. I was like, thank you. I was wondering why is it not working? Okay. Yeah. Okay. Bruh. Give me a second. Oh, it's this. Here we should go back. Okay, yeah, now it's working, yeah. So thank you for pointing out. I was wondering that because it should work. So yeah, so here is a way of putting 3 different conditions all together in one line and you print together. For those who hate figuring out indents, you can try to use this method, but I highly recommend you to not to, because again, as we saw, it's confusing. And then for people who's reading your code, it's not easy to figure out what's going on in your code. So it's just an option that I'll introduce to you guys. All right, let's again make this gray. Oops. And now let's go into for loops. And if you have ever used a programming language before, you're definitely familiar with for loops. And a for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. This is less like the for keyword in other programming languages and work more like a iterator method as found in other object-oriented programming languages. With the for loop, we can execute a set of statement once for each item in a list, tuple, set, etc. So now, before we start, let's go back and draw a flow chart. Okay, well, let me switch to my Notability. Are you guys seeing Notability now? So flowchart for loop. And now, unlike we just simply do the input, we call it for each item in sequence. Again, it can be any sort of arrays, right? List, tuple, whatever. And then we reach last item. We have a question if the last item is reached, or the last number, last string, or last whatever in your list. And if yes, we reached the last one in your list, we do exit loop. And no, they haven't reached body of 4. and then it would go back and go to the first question again if the last item reached, and if no, it would keep circling through your array and until the last item in your array is reached, and then it would go exit the loop. And now let's start with some examples in Python. Okay. We call this project print each fruit in a fruit list, right? Print each fruit in a fruit list. We call it fruits. Again, it's a variable. It can be anything. And we create a list. And like I mentioned, we don't have to just do numbers or integers in list. We can also do strings. Right now we have fruit names, aka strings, banana and cherry. And for, let's looping through our items, right? For I in fruits. So usually we use I, aka stands for items, in the inside to refer to each variable inside a list or parameter or index, whatever you call it. But here it doesn't have to be. It doesn't have to be I. Again, it's more like a variable name to refer to the each item inside your list. Or it can be X, it can be Y, it can be anything. So like when I literally just got into the programming, that actually confused me a lot. Why everyone uses I. But yeah, that's just like a commonly used variable name. Okay, so now we print I. Oh, wait, let me see it again. For I in fruits, apple. Why this is... Oh, my bad. There, it shouldn't be I, because once I did the parentheses, it would be not parentheses, the quotation mark. It would make I itself as a string, so it would just literally print out Y. And now we run it. So I is a variable, so it should not be a string. So that was a problem. So now we see that we print apple, banana, and cherry in our list. And now we can also looping through a string or a list. 1 second. Okay. Looping through, so for X in, again, let's make those gray so we don't get confused. So for X in, let's do a string. This is a string full of random numbers, and we print X. Right, so it will print out each item inside our string separately, and we can just call it apple. Right. So now we print everything inside our string apple. Again, inside each quotation mark, it's a string. So every item in the string is APPLE, right? And then let's looping through a list. We already did that in here, but instead of creating a list first and then looping through it, we can just put the list name in here. So for X in list 1, 3, 4, 5, 8, you can also like add strings to the list. And print X. So now we'll print out every item in the list. And again, we can also have listing list. 1, 2, 3. Right, see, now we print a list. It's a listing list. And now what if we want to stop our looping process and we can use something called the break command? The break statement was the break statement, we can stop the loop before it has looped through all the items. So sometimes if we want to like search one variable inside a very long list, we don't want our program to go through everything that's kind of complicated. The time complexity is just insane. So we want to break it if we find what we need to find. And again, let's go back to the flowchart and see what it looks like with break. Okay. Now you guys are seeing Notability, right? Okay. And this is called flowchart for break. Break flowchart. And we enter the loop. And we test the expression of loop. And let's see again if it's true. We decide if we want to break or not. And no, if we don't want to break, it will go through the remaining body of loop. And once we go through the remaining items, it will keep going back through the beginning of the loop and run through the process again. And if the test expression of loop is false, right? We don't meet the condition, then we would exit loop. False. Exit loop. And if the break is true, is we don't want to break, then we go through remaining body. But if we want to break, then we would go to the last step, jump outside the loop, aka exit loop. And that's a flowchart for the logic behind the breaks inside the loop. And now let's go back to PyCharm. Okay. And see one example. I'll just delete those. And we want to exit the loop when we meet banana. So we want to find the banana in our fruit list. And I'll just copy, well, I'll use the same lists we had. We can add more to it. We add peach. We can add watermelon. And we looping through it for X in fruits. Print X if X is banana. Break. So we see that we print everything inside the list, including banana, and everything behind the banana we're not showing. So basically what it means is that the loop runs through apple, and then if we go back to flowchart and see did we break, and it will go no, and then we go back to the beginning of the list, and then we'll go to the next item, which is banana, and then the break, it would be yes, we break, and then the loop stops, and then it will not run through everything left inside our list. And let's do another example. We exit the loop when X is banana, but this time the break comes before the print. So what this means is I will move the break item to we will not print over here. And if X is cherry, break here and then print X. So if we run it, we'll see that we get the same result, but the X is cherry. So this time we break after the banana or before the cherry, right? So if we change this into banana, it will only return apple. So the reason that this happened was because we break first and then we print. And that's why cherry was not included. And let's do banana. Right, so now it will only print out apple. See, the position of the print and break is very important. If you guys have any questions, feel free to let me know. And the position of print is also very important. And let's do a quick exercise. And this exercise is a little bit different, is that I do not want you to run in your program, but just look at it and tell me what is the return. So we have for X, and let's do cherry. Okay, so for this function, please tell me in the chat what is the result of this function, or what it would show in the console for this for loop. And do not run your program. And just by looking at it and think in your mind and tell me. Okay, we got apple, banana, and cherry, and we got apple, and we got cherry. I'll wait one more minute till 4:10 to see if we got cherry. Okay. Okay, we got. Okay, this one we got apple, banana, and cherry. Wow. Why would be 2 apples and 2 bananas though? Okay, let's run it. Yes, we got cherry. And this is a little bit tricky because remember our print is under this if statement. So despite if there's a break or not, it would only print cherry because the condition is that if X is cherry, it will print. So if X is not cherry, it will not print. right? It's a little bit tricky. So if you are a little bit confused about the process, do go back to our flow chart and then follow step by step and see how it works. And I remember there was a website that shows the steps by step, the steps of those loops and stuff. And I will post, the website is inside our Jupyter, not Jupyter Notebook, the Colab notebook, and I will post in the chat later when we go to it, but don't worry about it right now. Right now it's still easy. And okay, so if you didn't get it right, don't worry. It is very confusing, and I gave very limited amount of time. Like I only give you like a few seconds to think about it. So yeah, it is tricky. So don't worry about it. And there, besides a break, there is something called the continue statement. And with the continue statement, we can stop the current iteration for the loop and continue with the next. Do remember to mute yourself because I heard some background noise. Okay, so let's change the break to continue. For X in fruits, X. Now we still use banana. And we continue. Print X. And what this means is we can see that we print out everything inside list except for banana. And what that means is, again, the definition of continue is that we can stop the current iteration of the loop and continue with the next. So what happened in this process is that when the program runs through the fruit list, we go through apple, it's fine, and we went to banana, and yes, it meets the if statement, and we stop, and then we continue to the next, which is cherry, peach, and watermelon. So that's what happened. And also, we mentioned many times there is a range function that defaults to 0 as a starting value. I'll show you the range function. So that's a function that defaults to 0. What that means is the index number is 0, right? Everything starts from 0 as a starting value. And now we can specify it to a different range from starting to the end, and then with different steps. So now we do a for loop in a range of numbers to see how it works. Command. So there are some hotkeys, like if you saw me just commented, like fast commented everything, there are some hotkeys inside of PyCharm that you can use. It's different for Windows and Mac systems or Linux. So if you're, they're quite helpful. So if you're also using PyCharm, feel free to look up some hotkeys. And now we do a range for X in range 2 and 16. Print. So now it will print from 2 all the way to 15. Again, why it ended at 15 was because the 16th condition ends at 15 as it started from 0. So think about that, 0, 1, 2, 3, right? And if it start 0, 1, 2, 3, and if it start from 1, we would think it's 16, but it started from 0, so ended at 15. So again, for the numbers, for the range function, numbers is always starting, period, and number minus 1, and then steps. So we can print out we want to print every 2 steps, and we run it. So now we start from 2 and skip 3 and then print 4 and then skip every 2 numbers inside our list. And the range function can be given up to 3 parameters. Again, start, stop, minus 1, and step. I'll type it here. Start, stop -1, and step. Oops, my bad. And I used a bracket over here, but to show a function, but the range function is not a bracket, it's a parentheses. And as we slicing into the strings and lists, the loop will stop at stop -1. So, and let's add else to this condition. For x in range 6, I'll make it shorter. Let's do 6. And then print x, and then else. Someone asked, the range is like 2 to 16. Yeah, you can interpret it that way, but I wouldn't like you to interpret it like that because it's different. If you missed the last class, I'll quickly catch you up on that because that's very important. Let's go to Notability. Okay, so what happened with this index is that the reason that's from 2 to 16 but shows 15 was because let's say we have a string, right? The string is hello. So what we have inside hello, we have HELLO. We have 5 different items, and each item has a position number. So it starts from 0, 1, 2, 3, 4. So when we do, let's see, we print out a list, and if we want to do a list name, let's say X, we print out 1, right? It will not, when we print that, it will not show you the first one. It will show you the second one as it starts from 0. So it would print E instead of H because the position starts from 0. So the reason that from 2 to 16, 1, 2, 3, 1, okay, I'll do it. It's kind of messy. Like 1, 2, 2, 3, 4, 5, 6, right? So now 2 has a position number of 0, and 3 has 1, 2, 3, 4. So what inside a range from 2 to 16, it's not pointing towards the number itself. It's pointing towards the position number. So when it's pointing to the 16th position, and that will show as 15 because we need to -1 as it starts from 0. And that's why it's 2 to 16. Okay. All right, now let's go back to PyCharm. That's something we covered in workshop 1, but if you missed it, don't worry about it. Yep, great. All right. Okay, so now we go to else, we print finally finished. And let's run through this program. So for this command, we see it has 2 steps for x in range 6. So what would happen again, it would print out from 0 to 5. And now you can see this clearly. For range in 6, it has this 6 refers to that we print the first 6 numbers inside a list. And the default list would be 1, 2, 3, 4, 5, 6. So now in range 6, it print out number 0, 1, 2, 3, 4, 5. And else, if it's not in 6 anymore, we print finally finished. So when we go to the 7th position, which aka 6, and the loop would go, the condition would jump out, or the function, the program jump out from the for loop and print out finally finished. And next concept, as we had nested if, we also have nested loops. And a nested loop is a loop inside a loop. and the inner loop will be executed one time for each iteration of the outer loop. This sounds very confusing. So now I'll show you guys some examples. And it is very confusing. So now we have, let's say we have different adjectives to describe our fruits. We have, let's say we have red apple, right? We have red apple, we have big apple, we have sweet apple, or we have tasty fruits. And here are some adjectives to describe our fruits, and we have fruits. I'll copy paste this. And then for X in adjective, and for Y in fruits. Right. X and Y. So here is a nested if. So what? Let's show what it would return in our console. And now this is very straightforward, as we see what happened is that first we run through the first item inside our X list, which is adjective list, and we get red. So once we get into this first loop and our nested loop Y, aka fruits, would the for loop would run through everything inside our second list or Y list or fruits list, whatever you call it. It would run through everything with red. So we see that we get red apple, banana, cherry, peach, watermelon, and everything. And once we finished, we would jump out of our inner loop and then go back to the outer loop and then to run to the second one, which is big. And it would run through everything again, big apple, banana, cherry, peach, watermelon. It's the same thing. So until everything was finished in our outer loop, and then our for loop is, the entire for loop is finished. And that's called nested loop. And so I'll show you guys some common use of for loops. As one use is to append elements to a list, right? So I'll make this gray as it print too much stuff. And we have a question: what are the first 10 multiple, what are the first 10 multiples of 3? I can't just type times, because okay, if I had a typo or spelling issue, just please forgive me. Okay, so we have my list. And the list, right now, let's don't put anything in it, and initiating the list. And this list can be any name. It doesn't have to be my list. It can be fruits if you want to use weather or whatever. And then for I in range, let's do from 1 to 10. 1 to 10, right? So we need to end at 11. And my list dot append. This is another function we mentioned earlier. We do 3 times I. 3 times I. And then print my list. And this has to be outside the loop. And then now let's run it. Now we get a new list with the first 10 multiples of 3, right? So what we did is we 1 times 3, 2 times 3, 3 times 3. So what happened is that from a range, so 1 to 11. So we got the first list, we can interpret it as we got an outer list of 1, 2, 3, 4, 5 to 10. And then we can interpret this as we get an inner loop of 3 times 1. So every time every multiples of the range of 3 would be append to our original list. And then our new list would be look like that. Okay. And in our last workshop, we also talked about a function called extend, right? Extend. And what are the differences between extend and append? So the difference is that dot append function, we append object at the end of our list or array or whatever. So for example, X is 1, 2, 3. X, that's a list, right? So now we X append. Now we want to append another list of 4 and 5. Now we see that the list 4 and 5 itself were appended to our list 1, 2, 3, but we append 4 and 5 as a whole list. And the difference of extend is that extend extends the list by appending elements from the irritable, which is we only append the items inside the list instead of the list itself. So the same thing we do extend 4 and 5. And now what we'll get is we've got one list of 1, 2, 3, 4, 5. See? So instead of append the list as a whole, it only append the items in the list. And that's the difference between append and extend. And now I showed an append in a for loop, and now let's do an append in nested loops. So now this gets really confusing and tricky, but let's do it together. So now I will make all those gray and start from the beginning. For I in range, let's make it from 10 to 15. My list. Create a list for J in range. Let's do 5 on each, so we do 16. And then we append my list dot append I times J. Okay, I'm not going to run it right now, but I will write down what happened inside this loop. So we see that we have an outer loop, our outer list, range 10 to 16. What that means is we have an outer list from 10 to 16 be 10, 11, 12, 13, 14, and 15, right? And then we have an inner from 1 to 6 would be 1, 2, 3, 4, 5, right? So what the result we'll get then would be one times 10, 2 times 10, all the way till 5 times 10, right? That'll be our first one. We run through the first, under the first item in the outer list, we run through the inner list of everything. And now we go to the second item in our outer list, then we'd get 1 times 11, 2 times 11, all the way to 5 times 11. Okay, and then we run until the last item, 1 times 15, 2 times 15, 3 times 15. I just literally want to do dots, but okay, so this loop ends at 5 times 15. Oh, sorry, 1 times 15, 2 times 15. All the way end at 5 times 15. Okay. And basically that is what happened inside our nested if loop. And then I will run the program. See? And this is what happened. Okay. So we have a website that allows us to quickly look at the steps of our functions. I will paste it in the chat. Give me 1 second. Let me go to that website and paste it down to you. Okay. If you get a different result, here is a website that allows you to see a step-by-step looping functions. If you're not sure what happened, you can definitely use this website and then put in your functions in this website and then see what happened. And if you still have questions, I will be starting my office hours at 4:40. We didn't get to cover everything for today as we still have booleans and we still have a while loop and some implementations and functions. So I will move this to next workshop next week. And if you guys have any questions for today's workshop, feel free to stay or hop in anytime between 4:40 to 6 p.m. And if the time doesn't work for you and you encountered any questions later, feel free to just email me and schedule an office hour with me. And one more thing is that after the workshop, you will get an email asking for feedbacks. And it takes only about 30 seconds to a minute. I'd be really appreciate if you guys can fill out that feedback. And that's about it for today. And also for workshop 1 and this workshop, I will be uploaded to the YouTube channel. And if you missed anything or you're not unsure about anything, feel free to go to that recorded list of YouTube and review it. Yep, that's it for today. Thank you everyone for coming and have a good day. Yeah, and I'll be back at 4:40 for questions and stuff.